everyone. Today we are going to solve some questions which will help you to solve the graded assignments. So the first question is, the lifetime of a light bulb is exponentially distributed with mean life of 18 minutes. So first of all, what is the PDF of exponential distribution? It is lambda e raised to the power minus lambda x, right? And the mean is given by 1 1 upon lambda, right? Okay. Now it is given that the mean life of 80 with a mean life of 18 minutes. So 1 upon lambda is 18 months. Fine. Now, if there is a 60% chance that a light bulb will last at most t months, that is the probability. Like, let us represent x. Let us represent the x as the lifetime of a light bulb. Okay, so it is given that if there is a 60% chance that a light bulb will last at most t months, that is x less than equal to t is given as 60%, right? That is 0.6. Fine. So we have to find out this value of t, like what is the at most t months that the chance that a light bulb will last is 60%. Fine. Okay. Now, let's see the solution. Given mean of an exponential random variable, we have been given the mean of an exponential random variable, which is 18 months. That is 1 upon lambda is 18. So lambda will be equal to, if 1 upon lambda is 18, so we will keep lambda here. So 1 and 18 will be here. So 1 upon 18 equals to lambda, right? Now we have to find out the probability that x is less than equal to t equals to 0.6. So we have to find out this value of t, right? So first of all, this is the CDF, and CDF of an exponential distribution is given as 1 minus e raised to the power minus lambda x, right? So here instead of x we are putting t. Fine. So 1 minus e raised to the power minus lambda t will be equal to 0.6. So like 1 minus lambda t is equals to 0.6. This will come here. So 1 minus 0.6 equals to e raised to the power minus lambda t. 1 minus 0.6 is 0.4 equals to e raised to the power minus lambda t. Okay. Now we will take log on both of the sides. Fine. So e raised to the power minus lambda t equals to 0.4. Now if we are taking log on both of the side, okay, log e raised to the power minus lambda t will be equal to minus lambda t, and this will be equal to log 0.4. Fine. Now I can take this minus sign here. So this will be equal to lambda t equals to minus of log 0.4. I can write it as log 0.4 raised to the power minus 1, right? I can write it as log 1 upon 0.4. Fine. So log 1 upon 0.4 is 2.5. So lambda t is equals to log 2.5. Now, now here the value of lambda was 1 by 18. So we have put the value of lambda here, that is 1 by 18 into t equals to log 2.5. Now 18 will come here. So t will be equal to 18 into log 2.5. Okay. So option C is the correct option. Fine. Okay. Now, next question. The probability density function of the time x between calls at the customer care is given by. So we have been given the PDF. Okay. So if you look into this, this is the PDF of an exponential distribution. Okay. And here 1 by 2. This is representing lambda, right? And mean of a lambda is represented by 1 by lambda. Fine. And here 1 by lambda is given as, here the value of lambda is 1 by 2. So putting the value of lambda here 1 by 2, this will be equal to 2. So the mean value is 2. we have to find out the probability that the time between the call exceeds the mean time. That is the probability that x is greater than equal to 2, you can say the mean time. Fine. Now let's see the solution. So the mean time is 1 upon lambda. By putting the value of lambda here, we get 2 as the mean time. So now here, probability that x is greater than equal to t. So here t is the mean time. Okay, and the mean time is represented as 1 by lambda only. Fine. Okay, so probability x, okay, so probability of x less than t is, this is a CDF, and CDF of an exponential distribution is 1 upon 1 minus e raised to the power minus lambda x, or you can say t. Fine. Now I have to find out the probability x less than equal to t. So I can write it as 1 minus probability of x less than t. Okay. Now putting this value here. So we will get 1 minus e raised to the power minus lambda t. Right. So opening the brackets, we get e raised to the power minus lambda t. Okay, so here we see that probability of x greater than equal to t is e raised to the power minus lambda t. Now putting the value of t is the mean time, mean is 1 upon lambda. So putting lambda, we get e raised to the power minus 1, and the value of e raised to the power minus 1 is 0.368. So if you look into the option, B is the correct option. Now, question third. The time that Jan Shatabdi Express will reach the Delhi station is uniformly distributed between 12 p.m. and 2 p.m. So, if x is representing the time, it is following a uniform distribution between 12 to 2 p.m. Okay. What is the probability that the train reaches the Delhi exactly at 12:30? So if we see this is a uniform distribution, that it is a continuous distribution. Okay, so if we have to find out the probability at that particular time, at that particular you can say a constant term, we say that the probability is 0, right? So let's look into the option. The probability that the train reaches exactly 12:30 will be, we would be integrating the PDF through 12:30 to 12:30 only, because we need the probability at that exact time, right? So, and if we are integrating through only one we can say only one number, the integration will be equal to 0 only. So since the area under the curve at a particular instant of x value is always 0, so if we have to find out the area under a particular instant of x, the value will be 0 only. Okay, because there will be no area, because if this is the continuous graph, if we have to find out this particular point, this area will be 0 only, right? Okay. Now question 4. The total duration of a badminton match in the Premier Badminton League is uniformly distributed between A and B with variance 3 square minutes. Okay, so x is following a uniform distribution a comma b, and we have been given the variance of x, which is 3 minutes square. Okay, the probability that a match will last at most 42 minutes, that is the probability that x is less than equal to 42, is 1 by 3. Okay, this is representing the probability that a match will last at most 40. Okay, it is given as 1 by 3. We have to find out the expected time duration of a badminton match. So we know that the expected value is given as a plus b upon 2, right? So first of all, we have to find out these both value, right? So let's look into the solution. Okay, so it is given that the variance is 3. For the uniform distribution, variance is given as b minus a whole square divided by 12. So this is equal to 3. Now we will multiply 12 here. Okay, so this will be equal to 36, and if we take square root both sides, b minus a whole square is equals to 36. Taking square root both sides, so it will be b minus a, it will be plus minus 6 only. So we have two values, plus 6 and minus 6. Now we have been given the probability that x less than 40 less than equal to 42 is 1 by 3. So now this is, if we see here, this is the CDF, and CDF of an uniform distribution is given as x minus a upon b minus a, right? So the probability that x is less than equal to 42 is 42 minus a upon b minus a. Here 42, here 42 is x, right? So in place of x we are writing only 42. So 42 minus a upon b minus a is 1 by 3. Fine. So now if in the previous we saw that b minus a is taking two values, plus 6 and minus 6, right? So we are putting here the value of b minus a as plus 6, because if we take b minus a minus 6, then a is less than b will be violated, right? If we are taking b minus a is equal to minus 6, that means the value of a is bigger, right? But we have some condition. The condition is that a is always less than b. So if this will not be satisfied, because this condition will be violated. So we are only taking b minus a as plus 6. So if we are taking b minus a as plus 6, so this will be, so 42 minus a upon 6 equals to 1 by 3. Let's multiply here. So this will be equal to 42 minus a equals to 6 by 3. This will be equal to 2. So 42 minus a is 2, right? So that means a will be taking the value 40. So if a is the value of a is 40, then the value of b will be, we know that b minus a is 6. So the value of a is 40 equals to 6. So the value of b will be 6 plus 40, which will be equal to 46, right? So the value of b is 46. Now the expectation is a plus b by 2. The value of a is 40. The value of b is 46. Divided by 2, it will be 43. Fine. Now question 5th. Let a random variable is uniformly distributed over a comma b with expectation and variance. We have been given expectation and variance. We have to find out the value of a, b. Fine. Now we know the formula of expectation of uniform distribution, which is given as a plus b by 2, and the variance is given as this. So a plus b, we will multiply 2 here, so we will get a plus b equals to 12. Now we are squaring both the sides. Okay, so a plus b square will be 12, square of 12 is 144. Now here we get, similarly we will multiply 12 here, so we will get b minus a square equals to 48. Now we are subtracting both of them. Okay, so b plus a whole square minus b minus a whole square will be 144 minus 48. This is 96. Okay, now if we open this, we are opening this, so b square plus a square plus 2ab minus, we are opening this will be equal to b square plus a square minus 2ab, right? Now we will open the bracket, we will get b square plus a square plus 2ab minus b square minus a square plus 2ab, right? So this will get cancelled, so we will be left with 4ab, right? So 4ab is equals to 96, so ab is equals to 96 divided by 4, which is 24. Fine. Now question 6. Let x be a uniform random variable with PDF given as this. So we have been given the PDF. Here the mod of x is less than equal to 5. If mod of x is less than equal to 5, then we can write it as x is going from x to 5, sorry, minus 5 to plus 5, right? So we have to find out the value of k. Now let's see the solution. So fx is k, the values of x is going from minus 5 to 5, and we know that the PDF of a uniform distribution is given as 1 upon b minus a, right? So here if we have been given some PDF, this is the PDF, okay, of a uniform distribution, and the values and the limits of x will be going from a to b only. So if we compare this, okay, we get, instead of 1 by b minus a, it is k, instead of A it is minus 5 and instead of B it is plus 5, right? So this is A and this is B, and K is equals to 1 upon B minus A. So in place of B we have put it 5 and in place of A we have put it minus 5. Okay, so 1 upon 5 minus 5, this will be 1 plus brackets open 1 plus, that is 1 by 10. Okay, now question 7th. The probability density function of a random variable x is given by, we have been given the probability density function of some random variable x and with the limits as 0 to 1 and fx is taking 0 for otherwise. Okay, we have to find out the value of probability of x going from 0.2 to 0.8. Fine. So we know that the integration of a PDF from minus infinity to infinity is 1, right? So the PDF is given as kx and the value of x is going from 0 to 1 and the whole integration will be equal to 1, right? So if we integrate the value 0 to 1 kx dx, so this will be, we are taking out k outside, so this will be equal to x dx, right? Now this will be equal to x square by 2 0 to 1, right? So putting the value of x we will get 1 by 2, right? Now this is equal to 1, right? So k will be equal to 2 only because k by 2 is 1, so k will be equal to, we will multiply here, so this will be equal to 2. Fine. Now we have the value of k. Now we have the PDF, that is fx is equals to 2x, right? Now we have to find out the probability that x is taking from 0.2 to 0.8. So we have the intervals from 0.2 to 0.8, the PDF integrating with respect to x. Okay, so x we will integrating the x, 2 is a constant term, will be taken out, so it will be x square by 2 from 0.2 to 0.8. Now 2 will get cancelled, so we are left with x square. Now putting the values of x, so it will be 0.8 x square minus 0.2 square. Okay, so this will be equal to 0.6. Fine. Now, eighth question. The traveling duration of time taken every day by train is uniformly distributed between 200 and 220 minutes. Okay, so we have been given that x is the total traveling duration of the time. It's following uniform distribution between 200 to 220. Okay, now what is the probability that the duration of the time taken is more than 215? That is, the probability of x greater than 215, given that on that day more than 200 minutes of the time was taken, that x greater than 200 is already happened. So this can be written as probability of x greater than 215, x greater than 210 divided by probability of x greater than 210. So I can write it as probability of x greater than 215 divided by probability of x greater than 210, right? Here the probability of x greater than 215 and x greater than 210 will be equal to x greater than 215 only, right? So let's see the solution. So we have been given that x denotes the duration of the time taken by train in a day and it is following uniform distribution 200 to 220. Now we have to find out this probability and this is equal to this. Now probability of x greater than 215 can be written as 1 minus probability of x less than equal to 215, and this is the CDF and I can write it as f 215. Now for a uniform distribution the CDF is given as x minus a upon b minus a, so instead of x we will be writing 215, so this will be equal to 215 minus the value of a is 200 divided by 220 minus 200, so this will be equal to 15 by 20. Similarly probability of x greater than 210 will be equal to 1 minus probability of x less than equal to 210, and this is the CDF. Okay, we will find out the value minus 200 divided by 215 minus 200, sorry this is 220 So this will be equal to 10 by 20. Okay, so now this value now we have got this value and this value. Now we will subtract this and this by 1. Okay, so this will be equal to 1 minus 15 by 20, which will be equal to 20 minus 15 by 20. Similarly, this whole will be equal to 1 minus 10 by 20. This will be equal to 20 minus 10 by 20. Okay, so these are the values. Okay, now 20 minus 15 is 5 and 20 minus 10 is 10. So 5 upon 10 is 0.5. So the probability that x greater than 215, given that x is greater than 210, is 0.5. Fine. Thank you.